Hello everyone, this is Mr. Choi. So in this video, I'll be talking about the last part of your EMI chapter, which is on this thing called a CRO. So you will need to know the name of this device. This is called cathode ray oscilloscope. Okay, and the details of today's video will be uh, reflected on worksheet 22.4. So you will need your 22.4 with you in case you want to take down some note. So I've included an actual picture of a cathode ray oscilloscope. You will see this equipment in your JC laboratory or your university laboratory. So in the chapter of EMI, you have actually learned how to generate an AC current, right, using a AC generator. You have also learned how to regulate the voltage or the current of an alternating power source using a transformer. So now with all this, right, you will need a device to actually allow you to measure the alternating current that you have. Now, why is it that you cannot use a typical ammeter for your alternating current? And that is because for your alternating current, the typical frequency is about 30 hertz. It means that the current will actually change its direction 30 times in 1 second. So if you are going to use your typical ammeter, which rely on a pointer to tell you the magnitude of the current, the pointer will keep on flipping 30 times in a second. And basically this ammeter inside is actually made up of spring and mechanical parts. And these mechanical parts actually take some time to respond to the change of a current. So when you have a frequency of 30 hertz, the pointer will not even respond to it because it is too quick. So because of that, you will need this device called an cathode ray oscilloscope to actually enable you to measure, for example, the frequency of the alternating current or the amplitude of the alternating current or the alternating EMF, depending on whichever mode you need. Now, I will just give you a very brief introduction of what the cathode ray oscilloscope is made up of. You do not need to know each part and its function. You do not need to know. It is beyond your syllabus. What you need to know in your syllabus is how to read from the cathode ray oscilloscope. Okay, and of course, you need like a brief understanding of how it works. So in a cathode ray oscilloscope, right, in this device, of course, this device, right, you will need a power supply. So actually, you will need to actually power this up using your 240 volt supply. So when you power this up, what happens is that inside there is this thing called an cathode ray that will actually emit electrons out of it. So when you power it up, the beam of electron will be produced, and there will be an anode inside this cathode ray. Basically, when this thing is being turned on, the electron will be like actually emitted in all direction. So the anode basically will try to one chunk of electron come out. All these are electron, and it will squeeze this electron into a beam. Okay, and this beam will just go forward, and it will hit. What happened here is that there is a layer of fluorescence. So when this beam of electron is being concentrated by the anode, it is pushed, it is focused into a beam, and the beam actually hit the fluorescence. The fluorescence will light up like a dot like that. So this light green color on the green screen is actually lit up fluorescent particle. So far, so good. Another feature of this cathode ray oscilloscope is that in it there is this thing called an X-plane. So what this X-plane does is that this X-plane is connected to a knob called the time base. Okay, this you need to know. So how does this work? So on your cathode ray oscilloscope, there are many knobs. One of it is called the time base. Okay, so basically what you need to know is that the X plate is connected to one of the knob, it means that you are in control, right? So this thing is user control one. Okay, what does this do? So what happens is that, let's say you have a beam coming out from the ray emitter. So this red color beam is the beam of electron. Then you will have a plate over here, and then you will have another plate over here. Okay, this plate is called the X plate. Now what it does is that these two plates is connected to the oscilloscope, and basically what the oscilloscope does is that it will give it a certain charge. At some instance, it will give it a negative charge, maybe a positive charge and a negative charge. And what will that what is the effect this will have on the cathode ray, which means the beam of electron, is that because this side is positive, this side is negative, right? The beam will actually bend towards the positive X plate. Then at some time, right, the oscilloscope will actually control the charge on the X plate, and it will change it to negative, positive. What it does is that it will slowly bend this ray towards the other side. So what you will see when this is being turned on is that the dot will appear here, because at first it is positive on the left side, right? Then the oscilloscope will control the charge on these X plates, and it will move the beam across like that. 1 time, 2 time, 3 time, 4 time, 5 times. That is the job of the X plate. Got it, huh? Then there is another feature on the oscilloscope, which is the Y plate. Now the Y plate is where you connect the sample to. You will connect it to what you want to measure, right? So for example, if you are connected to a AC power source, right? Let's say you connect these to an AC power source. I will just draw the Y plate. And you connect these two plates to, let's say, the AC power source that you want to measure. So what happens is that your AC power source will alternate is positive, negative, and then negative to positive, right? So sometimes it is like that, sometimes it is like this, right? So what will happen to the beam of electron? Well, the beam of electron is going to get attracted down, and then sometimes it is going to get attracted up, right? So if you just turn on the Y plate and you connect the Y plate to a AC source, what happens to the beam is that it will go like that, up, down, up, down, up, down, up, down, like this. Now the interesting thing about this is that if you turn on both the X plate and you have your Y plate over here as well, what will happen to the dot is that the dot will go left, right, right? It will go left, right, and then after that the Y plate will cause it to go up, down, right? The combined motion will cause this to go and you will get a wave, right? And this wave will enable you to actually read how frequent will the beam complete one oscillation. So you can read the frequency of the AC current. So for example, let's say I have some example on your 22.5. Okay, so if you read your 22.5, you get a few example on how to read the CRO, or you can refer to the textbook. But in essence, what happened is that, let's say I use this as an example. I'll give you a preview, okay? The x-axis, you can see this is your x-axis, is what we call the time base. So the time base in an oscilloscope they may give you is like maybe 2 millisecond per division. So what is 2 millisecond per division? This is one division. One box is one division. So if you look at this particular sample, you have this, right? You can see that it complete one oscillation in 1 box, 2 box, 3 box, 4 box. So we know that the period of this particular AC power source, the period of this particular AC power source is 4 times 2 milliseconds. That means I have 8 milliseconds. Then I can work out my frequency using 1 over T, right? So that's one. And other thing you need to know is that the y-axis of this is actually called the gain. So if you look at, let's say, this sample, you can see that the gain is actually 2 division, right? And they will actually tell you, oh, for this particular cathode ray oscilloscope setting, the gain is maybe 3 volt per division. So what is the peak EMF of this AC power source, or the peak EMF of this AC power source would be then 2 division multiplied by 3 volt, which is 6 volt. So that is how you read or interpret the reading on the cathode ray oscilloscope, and you can refer to your worksheet in 22.5 for some